Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Both A and B are 3,4-dichloro-5,6-dibromo. Structured around a central alkene with 4 stereocenters, 2 bearing Cl and 2 bearing Br, each also bearing a methyl group. Moving on to the next step. In structure A, both Cl substituents are on wedge bonds, pointing toward the viewer, and both Br substituents are on wedge bold bonds, also pointing toward the viewer. This means all 4 stereocenters have their halogen atoms on the same face. Moving on to the next step. In structure B, both Cl substituents are on dashed bonds, pointing away from the viewer, and both Br substituents are on dashed bonds, also pointing away from the viewer. All 4 stereocenters have their halogen atoms on the opposite face compared to A. And for the final step. Structure B is obtained from A by inverting all 4 stereocenters simultaneously. All wedges become dashes and vice versa. When all stereocenters are inverted, the resulting molecule is the mirror image of the original. The molecule has a plane of symmetry, C to symmetry axis, through the central double bond. The left half and right half of the molecule are mirror images of each other within each structure. Because the molecule has internal symmetry, it is a mesotype compound with a symmetry element. Inverting all centers gives a structure that is actually superimposable on the original by rotation. Specifically, structure A has both Cl and both Br on the same face, making it a meso-like compound with a C2 axis. Structure B also has both Cl and both Br on the same face, but the opposite face. Rotating structure B by 180 degrees about the C2 axis of the double bond superimposes it exactly onto structure A. Therefore, A and B are identical. A enantiomers would require the two structures to be non-superimposable mirror images, but here they are superimposable. B diastereomers would require same molecular formula and connectivity but different configurations that are not mirror images, not the case here. D structural isomers differ in connectivity, both have the same connectivity. Therefore, the correct answer is C. Therefore, the correct answer is option C.